Hey, sorry. Hey everybody, Mr. Bell's here. We're going to talk about Precalc A P-7 right now, and that's about absolute values, inequalities, and we're going to do some quadratic inequalities, basically things that'll get us solutions. That stuff. You're probably going to need your graphing calculator here today, but the first few problems, probably not. So I'm going to show you graphically, actually, I'm going to show you graphically first, and then I'm going to show you why we don't need the graphing calculator. So I'm going to go ahead and turn this on. Blow this one up right here. My first problem is the absolute value of 2x minus 4 is less than 8. 2x minus 4 is less than 8. So I'm going to go to my y equals, clear. I'm going to put in absolute value symbols, which is under math and num. Math is a key just below the alpha on your calculator, and num is the second one. And then we hit ABS. Newer calculators, again, are going to show those vertical lines like that. Older calculators are going to have ABS in a set of parentheses. So I'm going to go ahead and put this in 2x minus 4. And again, we want to know where it's less than 8. So I'm just going to go here to y2, and I'm going to put in 8. And I'm going to hit graph. And you can see that when we're talking about less than, we're talking about all the places that is below the red line. So it's going to be below the red line in all of this range. So if I want to go ahead and do this, I'm going to go second trace, number 5, intersection, enter, 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 and you can see that -2 is one of the solutions. And then second trace, number 5, move your cursor over. See this? Got to get it all the way over to the other one. Enter, 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 and you can see the other solution is at 6. Okay, so from -2 to 6, those are all the values that would work for this. So just to have a solution set for this, it'd be -2, comma 6. Excuse me, that's interval notation for that. So how does this work out? So what I have to do is basically solve two different things. I have to solve 2x minus 4 is less than 8, and I have to solve 2x minus 4 is actually going to be greater than -8. So when we change this from a positive to a negative with the inequalities, we have to flip the sign the same way we would on some of those other problems that you've seen before with inequalities. So let's go ahead and solve this one, and I add 4 over here, right? When I add 4, I get 12, so 2x is less than 12. Divide by 2, and I get x is less than 6. Hey, that's what that's showing right there. And then right over here, I'm going to add 4, and I get 2x is greater than -4, and then divide by 2, and I get x is greater than -2. So it shows me x is greater than -2, so number line, right? -2, x is greater than that, let's go in that direction, right? And x is less than 6, go in that direction. And you can see that those things just meet in the middle. That's my interval notation, the same thing that you guys saw from the other problem. So what happens when we have one of these things right here? So I got 3x plus 2 is greater than or equal to 10. So again, I write the original one, 3x plus 2 is greater than or equal to 10. And then I also write 3x plus 2 is less than or equal to -10. Move the 2 over there, I get 8. So I get x is greater than or equal to 8/3. And this one right over here, move the 2 over, I get -12. So 3x is less than or equal to -12. And divide by 3, and I get x is less than or equal to -4. If I do this graphically, here's -4, closed circle, going like this, and here's 8/3. Let's go ahead and put 0 right here. So 4 would be about there, and we want 8/3, so it's at 2 2/3. So if this is 2 and this is 3, we got 8/3 about right there. And that's going to be closed circle again and going to the right. So you can see that when we have these inequalities, the solutions could be like this right here, bounded. yet open, or unbounded and closed. Remember, closed circles mean they include that point, just like we would a bracket. Interval notation for this, just so that you guys can practice this again. This one would be negative infinity, comma, negative 4, bracket, union, bracket 8/3, comma, positive infinity, curved parentheses, just like that. And we took a look at the graphs, and that's good enough. You can practice this one. So what about something like this? What if I have 2x squared plus 3x is greater than 20, and all of a sudden I have a parabola? Well, I know that this parabola opens up, so I really am going to have something like this, and I'm going to have a line at 20. So when it's greater than it, it's going to be greater than this line on this section right here, right? And on this section right here. So I should end up, when I'm done with this, have solutions that look like this, where it has two branches that go opposite directions. So I'm going to go ahead and see if I can factor it first and see if those are my things, see what my boundaries are. So 2x squared plus 3x minus 20, I'm going to, again, equals 0. So I'm going to treat it like it's an equation first. There. One of those scarier factoring ones, but we can do this. I believe it. 2x and x factors of 20 are 1 and 20, 2 and 10, 4 and 5. And I need a difference of 3. I need a difference of 3. But remember, one of these numbers I have to double. So if I double the 1, they differ by 18. If I double the 2, they differ by 6. If I double the 4 and get 8, 8 and 5 differ by 3. That's my magic number. So the 2 must multiply the 4, and the 1 must multiply the 5. I know I need this to be positive 3, so the 8, or the 2 times the 4, has to be the positive 8, and then that's a minus, which means the two places that it hits the x-axis are at negative 4, and right over here at 2.5, or 5/2. So if those are the two places that it hits, let me show you a quick little picture here. It has to hit at negative 4, and it has to hit at 2.5. And since it opens up, it must look like this, going through there like that. Does that make sense? And we wanted to know where it was going to be. It was greater than 20, so it's the same thing here. It's greater than 0. Now that I can look back at the graph. So where is it greater than 0? It's greater than 0. All of these spots above the line. So my solution set for this is from negative infinity to negative 4, not including negative 4, because at negative 4 it equals 0, and we need it to be greater than. And union from 2.5 to infinity. And if we're not sure on that, take a look. We're going to go ahead and pop this section here, saying up on y equals, depending on the time of day I do this in the room, it either likes the lighting on it or doesn't like the lighting on it. So I'm going to hit clear and clear, and I got 2x squared plus 3x, 2x squared plus 3x, and I'm going to go ahead and put 20, just so you understand that even though I do the original one here, the answers that I got are going to look exactly like what we thought they were going to. So zoom 6, and I'm like, hey, that doesn't tell me anything, does it? Because 20's way up there. So go to my window and change my y max to 30. You can go ahead and do that too. It's good practice for you on your calculator. And I hit graph. Those are the two things. And I do second trace, number 5 intersection, enter, enter, enter. And you can see there's the 2.5 that I got when I factored it. And second trace, number 5, move my cursor way over here, enter, enter, enter. And you can see there's the other one, negative 4. So I was able to solve this thing without the use of technology, but I just showed you that technology definitely agrees with what I did algebraically. Okay, so let's do one of these things here. X cubed minus 25x is greater than or equal to 0. So this is a cubic function, and most cubic functions look like this. So it could be greater than or equal to 0 from here on up, in different places, from here on up. I don't know. I'm going to have to try and find out where it actually equals 0, and then I'll know how it goes. Okay, so my first thing is I'm going to factor this, and factoring like a dentist comes into play. So I can pull out an x, and then I have x squared minus 25. Good deal. And then I know that I have an x, and I have an x plus 5, and I have an x minus 5, which means that this graph right here touches the x-axis, or it equals 0 at these places, at negative 5, at 0, and at positive 5. Okay? Well, if it's a cubic function and it's got a positive leading coefficient, that means it's got to do this. It's got to come up from the bottom, go up here, come back down, touch 0, come back up through 5, and end up heading towards positive infinity. If this was a negative leading coefficient, it would go the opposite direction and do that. Okay, so this is what it has to look like. So we want to know, where is this greater than or equal to 0? Well, in all of this range, it's greater than or equal to 0. And all of this is greater than or equal to 0. So my solution in interval notation will look like this. Negative 5 comma 0. And since it can be equal to, we'll bracket it like that. Union 5 comma infinity. Good deal. And I was able to do that without the use of any technology. If you could pause the video right now and go ahead and graph that yourself and see that what I just did is exactly what you just got. Okay, so let's go ahead to this one right here, and I'm assuming you just graphed it. So I'm going to try this one out again, set it equal to 0. So I got 3x squared minus 12x plus 4 is greater than 0. I'm going to see if I can factor it. I don't know if I can factor it or not. Okay, so 3's factors are 3x and x. Factors of 4 are 1 and 4 and 2 and 2. And I need to be able to triple one of these numbers and then have a difference of negative 12. And you can see that if I triple the 4, I get a 12 and a 1, but they differ by 11, or actually, I need them to add up to it. So 12 and 1 is 13, and 6 and 2 is 8. So this is not factorable, which means if we want those solutions, we're going to have to graph it. Okay? So let's go ahead and plug this in on the graphing calculator. See if we can find whether or not this thing actually works, or if it's like we had earlier in some of the stuff, imaginary solutions. So I'm going to go to my equation. I'm going to go ahead and do the secondary one. So 3x squared minus 12x plus 4. And I'm going to compare this to 0. And I'm going to hit zoom 6. And let's see. Looks like it actually is greater than 0. From negative infinity to whatever that point is. So let's see if we can find it. Number 5, intersection. Enter, enter, enter. Looks like it's hard for me to read. I'm getting older. 0.367. So negative infinity to 0.367. And I don't care that we rounded it that much. It's not that big a deal. Union, and now we're going to find the other little branch right here. The other little branch. So second trace, number 5. Move your cursor over here, like that. Enter, enter, enter. and I got 3.63. So from 3.63 comma to infinity, just like that. So those are my two things, my two solutions for that inequality. Okay, so we are good. We've done a lot of algebra, and I've showed you how you can do absolute values by hand or with a calculator. I've shown you how to do quadratics by hand, factoring wise, or with a calculator, and even did a cubic right here that we knew that we could pull something out of. We're going to end with projectile motion problem though. Okay, so you might want to pause the video and write all this stuff down. So you guys know that anything on Earth is affected by gravity, and gravity pulls objects towards the Earth, not at a consistent speed, but they get going faster and faster and faster the further that they drop, until they reach something, of course, called terminal velocity, which means, hey, it can't go any more than a certain amount. But we're going to use this formula right here, h equals negative 16t squared plus vt plus h sub 0, to represent projectile motion on Earth. Now, I want to be clear on this. If you did this in physics class, lots of times you don't use feet, you use meters. So instead of this 16, you might have a 1/2 and a 9.8, or you might just have a 4.9 in there. Okay, so what is t? T is time in seconds. V is velocity in feet per second. You got to make sure that your units are in the right units, so feet per second. This t again is seconds, so this t and this t are the same things. H sub 0 stands for the height at time 0, or the initial height, whatever the startup is. And big H of t stands for the height of the object at whatever time that you want to plug into this function. Okay? So I've got this statement right here. It says a ball is thrown with an upward velocity of 106 feet per second from an initial height of 12 feet. Awesome. So then we're asking 3 questions. How high does it go? How long is it in the air? And what time range is it over 100 feet? So from what amount of time to what amount of time is it at least 100 feet in the air? Good deal? Well, it's pretty hard to do this with factoring, or I can find the vertex and stuff like that, but all of this is really about using your calculator. So we're going to do some applications. We're going to try to see if we graphing calculator, and I need to start with this equation with the stuff in it. So negative 16t squared plus 106t plus 12. Again, velocity goes right in here in feet per second. It's positive because we're throwing it up. If we were throwing it down, it would be negative. And if we just simply dropped the object and didn't put any velocity on it at all, just let gravity take an effect, that would be 0. And 0 times t would drop out, and we wouldn't have to have a middle term whatsoever. Okay? So at this point, now that everybody has this equation, we're going to go to our graphing calculator, and we're going to try and answer these 3 questions. Okay. I'm going to zoom in way down here again. I'm going to turn this on and focus that in for you guys. Okay, so we need to get windows that match up with this stuff. So first thing I'm going to do is I'm going to go here, and I'm going to put in negative 16 x squared plus 106 x plus 12. Now, if I hit zoom 6 right now, that would be a really dumb looking window, because it doesn't really show, except this is 10 seconds before we threw the ball up. This is 10 seconds after we threw the ball up. This is a height of 10 feet. And remember, it started at a height of 12 feet. So that doesn't do me any good, right? This, again, is seconds. This is feet. I want to get a window that matches much better. So on my window, I might go 1 second beforehand, and I know that it lands within 10 seconds because I did see it come through on the other thing. So -1 to 10 is totally good there. Y min, Y max, it's 106 feet per second to start off with. So I'm going to put it at 250 feet, and then my Y min, I'm going to put it -50. I only do that so that I can see the bottom of my calculator screen show up pretty good. Now, I might be wrong on this. When I hit graph, I might have to alter it, but it might be okay. And I feel pretty good about that. Okay, so first question on the paper was, how high does it go? Well, the height is that point right up there. So I simply hit trace, and I go up here, and I can see that that height is somewhere around 187. Right, do we see that? But I really want to know exactly what it is. So I hit second, trace, and I choose number 4. That's a maximum. I move my cursor to the left of the high point. I hit enter. I move my cursor to the right of the high point. I hit enter, and it'll show me whatever is the point in between these two things that's the highest. I hit enter one more time, and you can see it's 187.5625. So I go ahead and write that in, 187.5625 feet. There's my answer. Good. Next. How long is it in the air? Well, it's in the air, it's in the air, it's in the air, it's in the air, it's in the air. Poof, it hits the ground right there. So I need to find out what that point is right now. That's when the height is 0. So I'm going to go ahead and just go to y equals. I'm going to put 0 in for the other one. I'm going to hit graph. And I need to find out right there where the blue and the red lines intersect. Second trace, number 5 intersection. Move my cursor simply closer to that point. Enter, enter, enter. And height of 0 at, you guys can see that right there, 6.736. So I'm going to go ahead and round it, but not too much. So 6.74 seconds. Good deal. And then the last one. What time range is the ball at least 100 feet in the air? Okay, so I'm going to go here. I'm going to go to my y equals. I'm going to put it at 100 feet. And you can see that it's above 100 feet from this time to this time. And that's kind of why we put this problem in right now, because that's a range, right? So from here to here. So I'm going to go second trace, number 5 intersection, enter, enter, enter. I see that my time here is 5.65. So there's my left-hand range. And they don't have to be perfect, but give me at least to the 100 spot. And let's find the other one. Second trace, number 5 intersection. Move my cursor over here. Enter, enter, enter. And I can see that that point is 0.973 seconds. 0.973. And I have that. Okay, so hopefully this was good. One more time, this is using projectile motion, ranges of values on a quadratic equation. This formula, yes, this formula is true every single time for whichever you need it for. Good deal. So this is the end of chapter 1. Hopefully you've done some good stuff. You've watched the videos. You've paid attention to it, you've taken good notes, you've worked on the homework, and you're going to rock star out this test when we come to it. Again, this is 2020, second trimester, Precalc A with Mr. Bells, and so far so good, despite the fact that COVID is in our house right now, and I'm not feeling great. My voice is still here, and I'm still talking to you guys, so take care. Bye now.